So, welcome to Rise of the Data Engineer, which I like. It's very Star Wars-y, sounds like we're attacking lots of people, which is all very good. We're going to run a fairly relaxed panel, I think is the plan today, just to have a chat around data engineering, what it is, why is it so popular right now, what it actually means, what are the pitfalls, why are we doing it, all that kind of stuff. Before we do quick intros, quick show of hands. Who's a data engineer? Yes, my people. Love it. Okay, sounds good. Right, so let's get on. Introduce some people. If you want to go down a quick intro, let's see who we're talking to.
Sure. Hi, Adam. I'm Locker. I am the head of data architecture and engineering at National Highways. We run the big roads, and we're just sort of trying to fix the plumbing of government data one pipe at a time.
Conlon, I'm the CEO and founder of Merit Group. We typically harvest large amounts of data, typically from hundreds of public domain sources, and we distill all that data down into one sensible data set. So we do that in lots of different industries, and I'm the CEO and founder.
Hi, I'm Dan Keeley. I'm Chief Engineer at Hubb. We are an insurtech looking to apply a lot of modern automation technology to the broking process and basically improve the customer experience.
Hi, I am Adi Polak. I'm the VP of Developer Experience at Reverse. I'm working on lakeFS project that enables you to take advantage of your data lake and gain hands-on experience of the best practices in data engineering by using Git-like capabilities on top of your data.
Awesome, and I'm Simon. Hi, I think I forgot to introduce myself in the panel yesterday. My name's Simon Whiteley. I run a consultancy called Advancing Analytics, and I'm a giant Spark nerd, so I spend lots of my time on YouTube talking about Spark, because, you know, I love it. So I'm opinionated about what an engineer is because I'm a Spark person. Doesn't mean I'm right, just have opinions. So, we've talked data engineering, we've mentioned that term, we've got heads of engineering and that kind of stuff. What is a data engineer? It's a big question. Who wants to go?
Adam, we'll let you go first.
Oh, go on then. I rather glibly said before we started that the data engineer is someone that comes and cleans up behind the software engineer, and I think that's probably a half-truth, because we need them to provide the structure that we've perhaps forgotten to provide as we're developing and building products, to giving them to our users. And it's come out of necessity. And it's a combination of someone who's also cleaning up after 3 or 4 decades of technical debt that all these organizations have let accrue. So that's my hot take.
Okay.
Yeah, I'd love to see it as a huge range of the way we work with data, going all the way, like you mentioned, the software parts, like the logic parts. So sometimes we have logic data engineers, the people who actually create the ETL logic or SQL. And then we have the infra folks, the folks who really handle and manages the low-level aspects of the data, such as orchestrating data management of governance, where the data is, PII, security, compliance, all this good stuff. So I see it as a big range of skills and big range of how they are supporting the business aspect.
So I think a more possible historical idea of a data engineer is, for me, it's someone who has typically come from a business intelligence background. Remember, that's what it used to be called. And it's probably someone who has chosen to more focus on the back end of that business intelligence. They may not be as interested in the front end visualization, and so they've fallen into this role of data engineer.
It's a data troll. Lives in the cave, shuffles data around. That makes sense. I mean, so for me, we were talking about this earlier, and the idea of engineering, that engineering term that you're finding jammed into so many job titles these days, it has meaning, right? So we're talking about software engineering. We're talking about the application of software engineering principles. We're talking about cleanliness of code, repeatability, testability, modularization, good software design, applying that to the world of data. So if you're an ETL developer, you're building out packages to move data from one place to another, you're not automatically a data engineer. It's taking those same principles, the data management, the knowledge of ETL, the knowledge of business intelligence and all that stuff, taking the knowledge of software engineering and good code practices and learning from, real developers, not data people. And then taking some of the things from the big data world and parallelism and scale and jamming that into one role. And that's a big role, right? There's a lot inside there. Is that fair?
Yeah, I think that's fair. I think it is a big role now, and certainly bigger than it was 10 years ago. I think, and they are kind of jack of all trades, and you have to, all of us have to work with the world as it is, and there may have been a lot of crap built that the data engineers have to kind of mop up, and you make your peace with that, whilst also thinking about the future and thinking about design questions and trying to move data engineers back to that engineering bit and the design bit for their businesses. You have to be able to do both and head towards the data architect side of things as well. But it's a much bigger role than it was years ago for sure, and as dominant as software developers are now for sure, and as important I think. But there is this, it is a role in which everything is chucked at it from BAU to kind of design thinking. But just embrace that and just work with it and develop along it, I think.
Yeah. Full stack developer / modeler / tester /
architect. Yeah.
I think we can get a bit hung up on the engineering part. I think anyone that has made data more useful or usable to someone is on the right track, and you're all right with me. I think that's, the semantics of what it is doesn't matter, it's the outcome that matters. Yeah. Could you make a better decision? Was there more clarity? Was there less effort? You're probably doing data engineering in some way.
Yeah, I think if we will go back 10 years ago, it wasn't data engineering, it was more big data. And then marketing kind of killed it with there's no ROI in data, right? We're investing so much money into building the infrastructure and processing it, but at the end of the day, we're producing a data product that doesn't really deliver on the ROI. So this is when engineering practice really go in play, because you want to be able to create high quality products. So if the data is your product, you want to be able to make sure it's of high quality and it really answers the product requirements that goes beyond just, having it there, supporting a specific throughput or volume, but actually look at the criteria from a product point of view, accuracy, freshness, all of these things that going to drive ROI for the business.
So in terms of, it's getting the right data in the right shape to the right people at the right level of quality. It's taking all the same ETL practices, but it's evolving it. But why has it changed? Why is it different? Why are we now suddenly seeing, if anyone's tried to hire a data engineer recently, it's a nightmare, because there is just this mad enthusiasm. It's just this explosion of popularity of the role and people trying to hire them. Why is that? Why is it so popular in the industry?
I think I think there's one big reason for that, which is tied into how a whole big data thing, which is it's not necessarily about big data, but variety of data. So I was talking to a startup a couple of weeks ago at a meetup, and we said to them, how many software as a service platforms do you think you have now? And this was CEO who was thinking about it. He was saying, I've got over 20 already. And so that means 20 different data sources that he, in theory, needs to connect in order to understand his system. Everything is a service now, software as a service. And connecting all those APIs is a massive job.
Yeah. I think there's 2 or 3 big macro trends. There's just so much data in the world now, from Netflix to Amazon to B2B scenarios, and it's getting bigger and bigger. And then I think we touched on earlier, we had the data scientist role come into focus because people want to get value out of that data. They want to spot trends. They want actionable insight. So data scientists were all the rage, but then they discovered they needed data engineers.
Yep.
To do all the grunt work and the donkey work to really serve up data that you could perform this analysis on. So I think that's the second sort of big trend as well. And then the variety thing. A lot of our clients are information businesses, so they make their money from data products. So we help scrape and collect and transform data from hundreds of sources and combining it with other API sources. Yep. So this new wave of stitching diverse varieties of data together is a new big challenge. And the world is not going to start using less data. We're going to, that appetite, as far as I can tell, is going to get bigger and bigger. That brings its own problems, but the data engineer is here to stay for sure. And one of our questions is it a bit faddish? I don't think it is. I don't see the world using less data anytime soon.
We've spent however many years treating data as a byproduct. It's what falls out at the end of the process when the job is done. And this is one of the things that I am firmly on board with the mesh approach is treat your data as a product. The data is the product. So if you do that part right, if the boundary around your service is nice and clear, and you can say to that domain owner, the data that comes from your service and the data about your service must be made available to your colleagues and partners in the organization. By providing those standardized ways of exposing that data, you can help. You'll still need data engineering to turn it into some sort of whole, but you will hopefully need to do fewer of those repeatable tasks or drudge work tasks over and over again. But the problem is that, yes, we're starting to treat data as a product from this point onwards, but there's all that stuff behind us that needs to be cleaned up.
I think one of the biggest problem with what we're seeing now is the full stack data engineer. Like when we're trying to break down the system and break down the area of responsibilities and ownership, we kind of expect a data engineer to do everything. So jack of all trades, and also adding quality assurance on top of it and all the good stuff. So, and this is like open question. How do we build the different, the work plan and the phases in order to go towards a data product while still being honest to the skills and capabilities of the team?
Yeah, I think I like this point about data. If we think of data as the product and not as a byproduct, and you know, Tesco with Dunhumphrey and their data is a large data business. We think of them as a grocer, but I don't know what money they're making from their data, but it's probably very, very substantial. And I think the more we think about data as a product rather than a byproduct, and people are, the higher ups are seeing that, the CFO, the CEO are seeing that, and therefore there will be more investment around data, and therefore that's why it's not a fad. It's not a fad.
I mean, and that kind of, in terms of that data as a product, in terms of that, you know, the outcome of an engineering workload is a data product. I mean, that was a conversation we were having earlier is, does a data engineer need to understand the domain? Do you need to understand the data that you're producing, or are you abstracted from that? And there's so many different ways you can tackle that question. It's a big, meaty question. I've got opinions on it, but anyone want to jump in?
I mean, I own a car. I can't change the crank in it, but I can change a light bulb if I need to. So I think, you know, there's a spectrum. It doesn't. You need to know how to change the tire, but I don't need to know how to rebuild the head.
Yeah, I can give an example about networking data. Okay, let's say we're capturing network traffic, so we have HTTPS and HTTP data. So how do we need to change our data structure in our table when we need to work with IPv4 versus IPv6? We definitely need to make a change in how we're capturing. So this is like one of the biggest example of, do I need to understand my domain? Yes, to some extent. It's going to impact how I'm modeling the data, which type I'm using, how do I operate on top of it. Do I need to be an expert in networks? Probably not. But again, depends on my role in the business and how big the company is.
Yeah, I think it does. That's the point I was going to make, is it depends how big your business is. I think in a smaller company, the data engineer will need to have domain knowledge. And you get that through osmosis and working in a business after a year or 2 years. And I think you need to, I think that can create bad disciplines, actually. Sometimes I think it's the data engineer's job to not have to dive into the murky world of that domain, strictly speaking. And I think that's where you're coming from, Simon. You don't think they should have domain knowledge, but
It's not so much that they shouldn't have domain knowledge. It's more so, consultants, I work with loads of different people in lots of different industries, and my role going in there as a data engineer is to build a bit of software that takes data, cleans it, puts it in a shape so that other people can then apply it and drive insights and build data products, analytical products out of it. Now I need to know how much data, what shape, how fast, what's it connecting to, all of that stuff. I need to know about the logistics of the data. Realistically, I don't need to know you're going to use that to predict that. You're going to use that to do that kind of thing. I can be told the rules by the data owners who are supplying the data and the analysts and people who are then consuming it. I just need to know, essentially, from a very, very theoretical, purist engineering point, what does this bit of software that repeatedly produces data need to do? So they can reuse it and use it to do many data products. We're not making one whole bit of software to produce one bit of data anymore. We're producing a generic framework platform to do that kind of stuff. Or certainly that's the way that we take it.
So I think if I was in the position where I'm looking for one of these rising data engineers and I'm employing someone, what would I be looking for? So I think of all the things I'd be looking for, I think the domain experience would pretty much come at the bottom. It would definitely be nice to have. It wouldn't be necessary that anyone I'd be looking for that would have insurance experience for me. I'd be looking at the tech skills, at the experience of dealing with the business, of course, and to know they've got the ability to take on the domain knowledge. But for me, it's not a number one priority.
Yeah.
And in my experience, I've worked across probably every domain, and I don't see differences fundamentally between different sectors.
Yeah, I think if you do focus on the purest engineer term, they should equip the end users with the domain knowledge to do all the analysis that they want. They should be creating the tool set to enable that. I agree with that. It's just in smaller businesses, perhaps, where you have the jack of all trades dynamic, they get sucked into legacy issues. But ideally speaking, yes, they would create frameworks that would enable people to self-serve a lot better. But real world.
But it comes down, so we call it personas, call it whatever you want. It's trying to understand there is a set of responsibilities that is a data engineer. Now, one job role, the person with the job title data engineer might be playing the data engineer persona and the analyst persona and a data science persona. They might be wearing lots and lots of hats. But we're trying to narrow it down to what is a data engineer, and we just focus on that ring-fenced set of responsibilities. It's kind of where I'm taking it from, going, well, that person might end up doing loads of stuff, and they're making some dashboards and they're going out to the business. But that's them doing a different function, a different hat that they wear, not their engineering hat. Is that fair?
Yeah.
And any more?
We're all somewhat hostage to the way that the combination of accrued tech debt and the way organizations are organized. Because in an ideal world, when, let's say we're building something in a service at National Highways, I would have a data engineer in that multidisciplinary product team, learning the product, knowing what's going on, speaking to users, and they wouldn't help but be able to pick it up unless they were, being willfully ignorant. But the problem is, because they're such a scarce resource now, and we have all this legacy debt accrued, their only job is to keep the pipes flowing and keep the lights on. And I think, we're going to talk about how do people get into it. We're going to have to find other ways to get more people into data engineering along the spectrum of what is data engineering, to share the load.
So good segue. How do you get into data engineering? Where do you start? What are the tech skills? What career path do you take? If you guys want to kind of elaborate as how you ended up in the world of data engineering, and then talk about if people are just entering it, people thinking about it now, where should they start?
So we talked about this earlier, and I think for me, number one is you've got to know SQL. There's still the language of data.
I was jabbing, going, do they? Do they?
It's not going away, and if you know SQL, the more important point is hopefully you understand the fundamental objects, data types, rows of data. You understand what data is, you can visualize it, and you can work with the right mindset. So for me, definitely, if you want to get into data engineering, first thing is SQL.
Interesting. I can share
Sorry, Adi, go ahead.
I can share my experience. So I actually came from the machine learning research area. So it's a completely different field. Like you're going deep into statistics and algorithms, designing algorithms, learning how to pack them all together. And what I realized after a couple of years, that actually data was a bottleneck. And I wanted to learn more about the data aspects, how to process big data. Back then we had Mahout and Hadoop and HDFS. Well, it was a lot of fun. The algorithms ran great, really. It wasn't a problem to get the statistics and all the good stuff. But data and having high quality of data and filtering it and fitting it, doing all the pre-processing was the big challenge. And actually, I started learning more data aspects. And for me, I really enjoyed the data aspects part, like how all these things comes up together. and I learned about the algorithms like the MapReduce algorithms, etc. So that took me to a data engineering role, working on building big data infrastructure. So it was a completely different path, but I came from the customer persona. Like, I knew what my pain is, right? So I knew what I needed. So it helped me build better infrastructure for people such as myself.
That's nice. You're building the thing that you would have wanted when you were doing that role. So, yeah, perfect.
Exactly.
Yeah, I think I agree. I think SQL as a foundation block is pretty important, given the legacy that you're going to bump into anyway. Python was another one, I think, indispensable. And so I think if I was a 21-year-old starting out, obviously, and a theoretical, I think, foundation around data as a topic, and understanding some of the theoretical basis of it and relationships and all that. In some ways, you could argue that might hold you back from new thinking and new technologies, but I don't think so. I think that foundation and a good theoretical foundation is actually, it disappears into the rearview mirror, of course, over time, but I still have an instinct that it's quite important. And then SQL and Python, you were talking about trends emerging and the number of...
Yeah, I mean, so certainly in the Spark world, so Spark is a Java-based technology. It was largely written in Scala. So Scala, functional programming language, very, very popular for old school data engineers. Yeah, I love a bit of functional programming. And that's changed. So back in the day, it was like Scala was, I can't remember what the stat was, 95% of all Spark jobs were written in Scala. And then Spark Engine changed. They actually sort of leveled out the languages. Now, if you write a job in Python, R, Scala, or SQL, it runs the exact same code. So there's no performance difference. And so if you speak to Databricks, you speak about the stats they see, it's now something like 45% of all jobs are Python, 42% are SQL. Scala's now just this tiny, tiny sliver. And part of that is accessibility. People know SQL. The data world runs on SQL, so if they can just take the SQL that they do and just run it on another platform, great. And then Python is just it's an easier language to learn.
Accessible, yeah.
It's harder to go wrong. Yeah, you can write some terrible stuff in Python and you don't have, it doesn't force you to have good type safety and all that kind of stuff. You can put it in. But we're finding a ton of people entering the industry with like a bit of Python, a bit of SQL, and then they can just suddenly get running. But it's the data literacy that's hard. The understanding of why data quality is important, how you measure quality, how you model data, why we have certain data modeling aspects, why Kimball's better than Inman, why Data Vault's no good in a lake. Loads of these different experience in data, that's really hard to learn. So we speak to people who are experienced, experienced in the BI world. They've been doing kind of analytics and data for years, and they're looking at this going, I'm going to really struggle transferring, I'm going to struggle to transition into a data engineer. And actually with the data literacy, with the understanding of ETL and the good data practices, that is one of the hardest things to actually teach. That is bitter experience. And then just learning a bit of Python, learning a bit of the software engineering things to apply to it is actually slightly easier than teaching someone who knows a bit of Python and teaching them decades of bitter data management experience. Fair?
Mm-hmm. Yep. I think you were making the point about pairing your team, Adam, earlier. I thought that was quite a good
Yeah, I always try and pair up, or I want to try and pair up my architects and engineers as the conceptual brain and the hard engineering brain, because I think together they're sort of a superpower.
Yeah.
I think as far as getting into data engineering goes, if I wanted to wind someone up, I'd probably say regex. But I think
an XML and JSON.
Yeah. I think useful, right? Nowadays you can sort of get away with learning via a product.
Yeah.
There's loads of them out there. Just go mess about with one. They've all got free trials, and just I'm one of those people that learns, and I need a tight feedback dopamine loop, or I will lose interest within an hour. And I think many people are like that. Some people might get value out of reading books, but I want to mess around with stuff and have that first hello world moment within 10 minutes and go find the products that do that best. I think there's loads of different ways into it. When I'm looking for data engineers, I'm really looking for smart people that can solve problems.
I think if you do the pairing up, because it's accessible via Python or SQL, and then if you pair them up with database architects and seniors, you can get a really nice combination. I think it's really important that we think about that and you think about pairing up the people at this end of the engineering scale with those that are seasoned. And in the work from home environment, that's easy to bypass and easy to ignore.
But I mean, again, we talk about learning from the software engineering industry, which data traditionally we're 5-10 years behind software development generally. Pair programming is a well-known thing that you actually improve your code if you pair program, and then people in data never do it because the teams are smaller or kind of they're very focused and it's kind of siloed. But absolutely pair programming to get that cross-functional skills transfer is a fantastic idea.
Really important. Yeah.
I think actually this is when open source communities are great because you're able to get the experience, you can try the open source, and then you can decide if you want to contribute back or write a tutorial or do anything that can be a contribution to that community and learn from other people in other organizations. So even if you don't work as a data engineer, or if you do work with a data engineer, but let's say you're the only one in the company, then you can grow your skills by collaborating with other data engineers in other companies. So it actually creates a really interesting ecosystem where you learn in the open and you gain hands-on experience and best practices from your peers cross-industry, in the industry, not just in one company.
I think the whole open source community thing has become more and more pervasive as well in our area. It's not just in software, it's not just in data engineering, but I've been following someone the other day who's a VC investor, and he has now started up his own business, and he's being open in all the pitches that are coming to him, why he rejected them, why he accepted them, and all that feedback is just open, and then it generates a massive discussion, and everyone's like, oh, that's really interesting, and everyone gains from it, and it's just, it's an incredibly collaborative community.
I mean, open source is a can of worms, which is really, really dangerous, because you get kind of big old corporations going, oh, we'll just use this open source thing, and not contributing back, and then essentially using the product of someone's labor for free. And it's like open source works if people contribute and people get involved and people do it, which again is something that the data industry, in the data science world, really quite common. It's actually fairly huge, people sharing these packages. In the kind of the traditional data BI world, no, it's mine, I'm not going to share that. And these concepts of actually sharing code in collaborative communities and becoming open source is kind of new to a lot of people. But then obviously there's big giant engineering frameworks that are open source. Spark is open source framework. Or they're also put out by people who manage it and they have a say and it's political and all that kind of stuff. But it's, again, things that are fairly new to that style, that sliver of the data industry that we're talking about.
Go and speak to a data engineer in your organization if you have one and just say, well, what do you know? Where should I start? Because if you start doing similar things to them, you've already got a support network there and they've got someone to share the misery of whatever you're working on together with. So I think you start there, and if you don't, there's loads of communities for different parts of data, from data engineering, open data, data policy, data ethics. Go and find one, turn up. People are generally generous with their time and their knowledge, I've found, for the most part. People are mostly nice.
Yeah. I do a lot with the Delta open source file formats. Again, big old Slack channel. Go ask questions. Look, really useful. Okay, so we've been trying to define the data engineer. We've been trying to tie a ring around all the stuff that they might do. If you're trying to get the most out of a data engineering team, what should they not be doing? If you had a team, what kind of work would you be going, no, that's going to be the death of your productivity. Where do you draw that boundary? And I know that's hard. It depends on the size of the company, but...
Yeah, so I've seen a lot of data engineers who are asked to build machine learning models. And I see a lot of people nodding their heads, so I'm sorry for you. Yeah, but I think this is where we should draw the line. There's a huge aspect of understanding the data and data quality, etc. But working with algorithms, oftentimes it's much more than just running a certain API to build a model, because you don't really understand why the results are the way they are. So if it's a big enough team, then it's better to bring someone who understands statistics well and algorithms well. But if not, it is what it is at the moment. But this is where I would draw the line.
Okay, it's fair.
So for me, I think operational day-to-day BAU. When I find myself having to fix a broken pipeline or kick something off manually or anything like that that could have been automated, that's always a big no-no. So absolutely automate everything. There should be no operational work, and you should be always focusing on new product.
That's the dream.
Oh yeah, that's the interesting bit, right? So,
But that's a valid point, right? If every time you finish a product and it goes live, wait, in production, you take on 10%, 15% of your work time is then supporting that thing, and then you deploy the next thing, another 15%, and slowly your development velocity just goes smaller and smaller because you've taken on so much overhead. But that means someone needs to support it. And again, it comes down to who are you building it for?
Yeah, and that comes back to Adam's point earlier about bad design, and if there is this kind of BAU hangover of 10, 15%, 3 or 4 of those, 60% of your time gone up. So this getting bogged down in kind of BAU kind of drudgery is a real, and also things like, I think when people are put under pressure, if your company does an acquisition or is doing 4 acquisitions a year and there's new data sets come into the picture and you've got to get those centralized really, really quickly and everyone's taking shortcuts, and then you end up trying to fix it on the fly. I think data engineers get bogged down with a lot of that, and taking them away from that engineering bit that we talked about earlier. We're trying to enable systems for people to work better themselves and to get the analysis they want themselves. So we move away from that lovely, really high value add engineering piece to integrating this latest acquisition that we got, and all their Salesforce data is rubbish, and we end up cleaning that data and trying to dedupe it, and getting bogged down in that stuff, I think, can be a great shame.
And again, as Adam mentioned a few times, technical debt. You build a thing, you take on the debt, it slowly slows down.
They should not wait for the product to be done before engaging with it.
Oh, is a product ever done?
Well, true. Or when somebody tells you it's done and it's now, you should be, you may not be able to be in that team full time, but you can talk to them, you can go to their show and tells, you can talk to them about, when you make a design decision about data here, this is the impact it has on me. If you just change this might make this easier downstream. Getting people to understand the downstream impacts of design choices on you and on others and on users is the number one thing you can do. You're always going to have to balance the keeping the lights on stuff against being there. But the earlier you get to it, the more likely you are to be able to affect a meaningful change on it to make your life. You're paying it forward to yourself, hopefully.
Yeah, I think shifting them to that design thinking, shifting your engineers to really thinking about design and design impact is the direction of travel you want to be on. It's not an ideal world, and there will always be these firefighting and these things to do, but if you're firefighting 10 months in a row, you've got to be having a conversation with your higher ups to say, this is just structured wrong now. We need to rethink our structure to do BAU and give us the time and space to think about design and somehow articulate that back to your CTOs or CEOs.
And it can be hard to articulate that unless you're thinking about it as a bit of software.
Yeah.
You know, if you've got a feature backlog, you're being agile, you got a list of stuff, and there's a story you're trying to deliver, and you go, time, it's tight, we're going to have to make a compromise on this, and that's going to add technical debt. And it happens because we don't have unlimited magical time and money. And when you do that, when you make that decision to go, right, we're introducing technical debt, you add that as a story to the backlog and you give it a size so that you can see this slowly creeping up amount of work that is technical debt. It's not an intangible thing that you've got in the back of your head going, oh, this is getting creaky. You've got this, there's a big chunk of work. And then you've got the argument, no, actually part of this sprint, we should bring in some technical debt. We should be, maybe 10% of our sprint should be fixing technical debt versus new feature delivery. You can manage it. But again, that's software dev principles and practices and ways of thinking, which is, again, fairly new to the data industry. Shouldn't be, but it is.
Data can be designed, and it should be designed. There should be design thinking put around how the data is structured, how you express the characteristics of a thing. Because very often you'll find that the easiest route is the blunt force route, and maybe data needs a little more, need to think a little bit more. How do we make data a little more elegant? How can it be designed well and be the tightest thing that we can design together collaboratively, rather than just you shovel it all over the fence and the data engineer will pick it up.
Poor data engineers.
Yeah.
Okay, so we said, so what should a data engineer not do? Machine learning, yeah, that's fair. I mean, we said, kind of BAU support, first-line support. Obviously, we might not always have the luxury of that, but if we're trying to design a good functioning team, absolutely. And then be blind to the overheads and technical debt and the meanings of things. Any other areas? What about DevOps?
Yeah, I get dragged into DevOps quite a lot. So
Yeah.
again, it's around how the resources of the business, and can you have separate teams, and like you were saying, people wearing 4 different hats.
Yeah.
It usually doesn't end well, or just flawed decision making because they're not experts, right? So, and that can cost. That can really, and then you blame the data engineer for some of those decisions. It's kind of,
I mean, it's a tricky area, right?
yeah.
Also, InfoSec, information security.
It's like, yeah.
It's a big problem when data engineers are asked to deal with PII data, etc. Like, as data engineers, we can definitely build the infrastructure to understand where all the copies are, who used it, being able to trace it. But later on, managing, like going beyond that and actually making sure it's compliant, it's a big problem.
Any other things we should draw a box around?
No, we can move on to your hype question.
Hype question. All right. So we asked this yesterday. Controversy. All right. What are the biggest topics? What are the biggest trends? What is going on that's going to disrupt the world of data engineering this year, next year, the years after? What should you be thinking about and setting your sights on as a data engineer currently?
I think what you mentioned about the practices, like how can we bring software engineering practices to data engineering world? Like we used to do a lot of SQL, data modeling, some of us been building infrastructure, Hadoop world, all of these parts, but how do we actually, when we think about data and not the logic part, so not the ETL and the compute, but actually the data itself, how can we engineer our data in a way that is actually engineering, that adds all the quality, reproducibility, and other aspects of modularity and aspects of engineering?
So I think we've gone through this time of great technological change. We've got amazing tools available to us now. We've learned all these things about good engineering practices and so on. And I think what this year is going to become is now we have to deliver value. It's all about ROI. Previously it was like, no, let's just build a data warehouse. The ROI will come. Like, did it? I don't know. Now it's much more nuanced. It's like if you're doing this project must deliver, and it must deliver its own ROI. So that's an exciting thing, because then you're delivering something that is proactively benefiting the business, and you can argue for a bigger bonus. So.
Oh, that's fairly depressing, though. What's the next big thing in data engineering? Delivering some value. But, we'll get there.
Quality gates. Quality gates is the next big one, in my opinion.
Yeah.
Being able to integrate quality gates into our production system. So when we think about pipelines, we're actually breaking these pipelines with quality gates. So before, and this is very engineering heavy, but before we're promoting the data downstream, we're actually running quality testing on top of our production data before we're exposing it to customers. And this is relatively new engineering concept in the industry, but this is something that we used to do pretty often with software. So
like things like great expectations, that kind of so many percent of the, 10% of this failed a thing, that's fine, no one will notice, it'll be okay. 12%, that's over a gateway. Don't bother processing the rest of it. That's a big red flag. That has failed its quality check. It shouldn't go any further, that kind of thing.
keeping yourself honest.
No.
Yeah.
Any other hypes?
Documentation's very hot right now, and I'm very pleased to see that. I think
hardly revolutionary, Adam.
We've just been through. Okay, well, we need businesses to understand that people own data and they are custodians for data. I think the next thing for that is somebody needs to own and manage the rules, the business rules that have the impacts on data. So the things that, if this then that on this field, is actually something that sits out in the business, is maintained by the business, can be contributed to and changed by the business, so that engineers don't have to think about that anymore. I think.
So I guess
we're
skirting around mentioning the word data mesh.
Yeah.
But the idea of data, product ownership of the data product by the business and by the data producers, actually, and just enforcing that and building that into the practices, absolutely. that fair?
Yeah, I think his other point was about trying to capture expertise and deep expertise in a data framework, and that's taxonomy challenges and just trying to bring common language around sometimes very technical expertise, and trying to bring that into a kind of data realm for the business to be more sustainable, for BCP purposes. So I think there's some interesting challenges there on the horizon. But I think we're seeing a lot of really good tools emerging that are used. There's not too much hype at the minute. We had a discussion yesterday on one of the panels, and I think sometimes it's just a bit too early. People get excited about a new emerging tech before it's kind of mature, and I believe in letting these things kind of just settle for a couple of years before diving fully in. But I think we're seeing a lot of things that makes everyone's life easier, the database engineers' life easier, but the end users, giving them more control and more access to the data. So I think that's all for the good, really. There will be definitely hypey stuff. DuckDB, Simon?
Yeah. I mean, there's loads of emerging technologies. There's loads of things that are coming out. DuckDB, we're talking about, is really getting loads of really good press because it's really, really fast. But then some limitations. We won't go into it. It's not a discussion about DuckDB.
Yes.
But what about other things coming out? What about low-code engineering? What about actually, currently there's this high-tech barrier to entry for engineering. You've got to be a bit codey, you've got to write some code, you've got to write some Python, you're writing software. And then there's tools coming out going, well, actually, just click and drag, just do that. Is that going to disrupt the industry? Are we all going to be out of a job in a couple of years' time if you can just click and drag it?
Stable diffusion for ETL. You put it in the prompt and it does the transformation for you, maybe.
Yeah, well, I think with the earlier point about just so much data in the world, and every single business is now generating data, and accelerated by COVID, of course. And so if those tools allow maybe less skilled people or people newly entering the industries, differently skilled, to get to grips and jump in quicker, then that's for the good, right? Because we're going to need more capacity, we're going to need more bandwidth. I don't think it's a sense of we'll all be out of a job at all. I just can't see that sort of in the short to medium term. So I think kind of low code or tools that enable us to do things a lot simpler, and then still shifting those data engineers up towards that design thinking and that engineering purist approach, I think that's all for the good. So the more of that we see, the better, for sure. I think we should all embrace that and try and make those tools work.
So I definitely think the low-code approach is going to be very interesting, because everyone, even normal operational people, are using tools out there like if that, then this, and that is kind of like an ETL pipeline, right? Albeit very simplistic. But the point is that vendors are building their platforms to work with those things as well. You've got to have an API, but it's got to be connective and it's got to describe the data that's available and so on. And I think when people are starting to see that, maybe we're going to move into an era of you've got the citizen developer, building low-code UI front-end platforms and all that sort of thing. Are we going to get a citizen data engineer?
Yeah, we're already seeing it, honestly.
Will that be terrifying?
Yeah.
I mean, so certainly we see absolutely that kind of. So you might have a centralized lake. I know, dirty word, centralization, because the industry is currently swinging toward decentralization. 5 years, it'll swing back to centralization. It's just what we do to keep us all ourselves in jobs. But there's currently an idea of, if you centralize a lot of data into a lake, and then you want to give people the power to build their own analytical products and to build, to say, well, go and serve your own stuff. You don't need to ask me to get the data. That kind of really accessible, kind of get some data, shape the data, put it over there. And that just brings the ability to do that to a much wider audience.
If you do the change management right and you get that audience bought into that, and they don't see it as you foisting a load of work on them, I think you've got to be careful that how you message that and how you get the data users to embrace that, or they just see it as another system they have to grapple with, even a very simple system.
It depends how prescriptive you are with it.
Yeah.
So if you say absolutely everyone has to use this,
true.
you're going to have some people fighting. But if you say, hey, look, if you want to use the data, here's some options. This is our preferred one for low code. You might want to do it in Python. You might want to do it in SQL. Here's so many ways to get at the data so that you can make it as decentralized as possible at the analytical stage.
Yeah, just how you do it. Just be careful about how you bring people on
until
that
you have 20 different standards.
So conceptually, often the logic at the end of the day is similar. Even if you use Python, Spark, SQL, they're still similarly inside of the logic and the API themselves. Specifically with no-code, low-code, and it's not the first time we're having this wave in the industry. It's actually this wave failed a couple of years ago. And that was because, and again, we're all learning, so I tried a couple of trials of the newer companies that came up. And when you actually dig into the logic, you see what they enable in no-code, low-code is very, very simple. So if you do want to make something that it's a little bit more domain-based for your business specifically, that means that you have to look under the hood of what that no-code, low-code generated for you. Some companies would enable you to actually go back and do the little bit of the twitches that you need to fit it to your business, but you'll have to learn their interface and how they model it. So some of them will have Spark underneath, but you will need as an engineer to go really deep into the levels to understand how Spark correlates to their interface, which correlates to the no-code, low-code experience that we're getting. So I'll just say, if it works for you with the capabilities that the use cases that they offer, it's great. However, if you need a more specialized domain relative to the data that you work with, so be cautious about the amount of efforts that you will need to put in as an engineer when adopting these products. And hopefully we'll get to the stage where it's finally matures and we can move boxes on our UI and things just work. But at the end of the day, we are data engineers and it's an engineering work. So there is still code involved or some SQL to write.
Maybe.
Being honest.
I hope there's still code to write because I like having a job.
Yeah.
All right, any other bits of hype, or are we good? Off the hype train?
I think off the hype trail, I think.
Off the hype train, okay. No one mentioned lake houses. No. Come talk to me if you want to know about lake houses. Yeah. All right, we've got a couple of minutes left. I just want to kind of just do a quick wrap up. So you guys want to just give a quick pitch as to why is it exciting to be a data engineer and what people should go do next in their engineering journey. And then we'll wrap up there if that's all right. So. This is a surprise question I've forced on.
I mean, you won't want for work. It's why it's good to be a data engineer. And I think the next stage is how do engineers encourage business domain experts, analysts, to find better ways of leveraging their knowledge for the benefit of their businesses, and providing the tooling and the support and the ways of managing that institutional knowledge that can be used into the future.
I mean, I think it's a great trade to be in. I think if you're a data engineer, more power to you. I think it's a brilliant space. Just again, by the sheer amount of data in the world, the fact that people are seeing data as a valuable entity in itself and as a product, as something that generates revenue. I certainly know our clients in Merit, most of them are data businesses. They're very, very good margins. Data is valuable. And so I think if you're in this space, it's a great place to be. And I think the emerging technology tools that enable us to do our jobs better are just getting stronger and stronger. So I think it's a great space to be in, and I think it will be for the next few years. I don't think it's faddish. I don't think we're going through a bubbly part of it. I don't see the world using less data in the next few years. So I think it's a really, really good industry to be in and a great profession to be in.
So absolutely. I think the excitement in data engineering now is that these things are so simple to build and connect together that there's no longer a technological barrier. So now it's more about your imagination and where you can directly work with the business and you can hook up these services together and you can build something that immediately adds value.
It's impactful,
and that's very exciting to see it being used. You know, you do this integration, and all of a sudden everyone's saying, "Oh, that's really great, and it's saving me, loads of time every day." And then they're like, "Oh, can we also do this?" And it just
and data engineering has impact, right? In the medical field, in your field, where identifying stationary vehicles, like that's important, right? Yeah. That's life-saving stuff. And so I think in all sorts of arenas, using data to understand trends and to make decisions is really, really, I think, really super important.
Yeah, 100%. I think what I see now is data lifecycle management. So after we figure out compute, we figure out SQL, we figure out Spark, now it's time for us to figure out data lakes. it's often a data mess or a data swamp. And so we need to be able to build the infrastructure that actually takes care and manages our data lake and our storage in a way it's going to support everyone in the company. So making sure we're baking in quality assurance, reproducibility, snapshotting, healthy snapshotting of the data, and all these aspects that we often miss on.
I think a lot of companies are realizing now that with cloud, it's easy, but we're now going through a phase of where you need to think about optimization again. I think it's the aggregation of doing lots of little things not as effectively as you could means you get a whopping great bill at the end, and I think data engineers are going to be asked more and more to understand the cost implications of design decisions.
Awesome. So to kind of just, to finish, holding up a sign at me. I mean, the final stat I will share is, so Stack Overflow do a yearly kind of the state of technology, what their trends are seeing, all that kind of thing. And I think it was this year, Python is one of the biggest programming, one of the hottest programming languages to learn. And the framework to learn that will earn you most money in your technology career is Spark, because it is taking off that much. So kind of, it's a good industry to be in, it's a good job to have, and there's lots going on. So, thank you, Adam, Con. Dan.
Dan.
Nadine, sorry. Thanks, everybody. Cheers.
There's